Alright, in this video I'm going to show the first couple solutions on the Chapter 4 test review packet. So the first problem is here. If f of x equals the quantity x minus 1 squared times cosine of x, then f prime of 0 equals blank. So we need to find the derivative and then plug in 0. In this case, we have multiplication, and to both sides of multiplication I see variable expressions. So I'm going to have to use the product rule here. For example, I might call this expression u, this expression v. So my derivative, f prime of x, will be found using u times v prime plus v times u prime. That's the product rule. Again, the product rule is used anytime you have multiplication and you see variable expressions to both sides. So, to get my derivative, f prime of x, I'm going to take u, which is x minus 1 quantity squared, times v prime. The derivative of cosine is negative sine of x. Again, this is multiplication here, not subtraction. Plus v, which would be cosine of x, times u prime. Now u prime, I'm going to have to use the chain rule here. I'm going to multiply by 2 up front, take that exponent down to a 1, let's write it like this, so times 2, that exponent goes down to a 1, and then copy down the x minus 1, then multiply by the derivative of x minus 1, which would just be 1. So I'd be multiplying by 1 right here. At this point, we could simplify, but I think it's better just to go ahead and plug in 0 next. F prime of 0 would be 0 minus 1 squared times negative sine of 0 plus the cosine of 0 times 2 times 0 minus 1 times 1. Thinking about our unit circle, I'll just draw a little unit circle down here. Here's 0 radians right here. That's at the point 1, 0 in your unit circle. So the cosine of 0 is 1. The sine of 0 is 0. That'll help us as we evaluate this. F prime of 0 equals, this is going to be negative 1 squared, which would equal positive 1. The sine of 0 would be 0, so the opposite of 0 would just be 0. Cosine of 0 would be 1. Here we'll have 2 times negative 1 times 1, so that's negative 2. So our answer comes out to 1 times 0, which is 0, plus negative 2. So our derivative of f of x at x equals 0 is equal to negative 2. Which, if this is multiple choice, so that would be letter A. You'd circle letter A on your test review packet. Number 2, the equation to the tangent line to the curve y equals 3x plus 4 over 4x minus 3 at the point 7, 1 is blank. So this time we're looking for the equation of the tangent line. So we're going to have to find the slope of the tangent line and use the slope and the point to write an equation of that tangent line. So to get the slope, we need to do the derivative. So in this case, I'm going to call it y prime, or I could call it dy over dx, equals, here you have an expression divided by expression, so you're going to use the quotient rule. The saying I usually use is low d high minus high d low over low squared. So low would be 4x minus 3. D high would be the derivative of the top, which would be 3, minus, always use subtraction in the quotient rule, high, 3x plus 4, d low, which would be 4, over low squared, 4x minus 3 squared. Then we're going to plug in 1, so we're going to find the slope of the y equation when x equals 1. So we'll plug in 1 here, so 4 times 1 minus 3 times 3, minus 3 times 1 minus 4, or plus 4, excuse me, times 4. Plug in 1 at the bottom also, so 4 times 1 minus 3 squared. This would be 4 minus 3, which would be 1, times 3, which would be 3. Here this is going to be 3 plus 4 is 7, times 4 would be 28. All divided by 4 minus 3, which would be 1 squared, divided by 1. So this comes out to negative 25. That is my slope. So that's the slope of the tangent line. That's what the derivative gives us at the point 1, 7. Now to write my equation, I'm going to use point-slope form of a linear equation. I'm going to go y minus my y-coordinate, which is 7, equals my slope, which is negative 25, times x minus my x-coordinate, which is 1. That's my equation of my tangent line. But if I look at my choices, this is a multiple choice question, none of them look quite like that. What I need to do is distribute the negative 25 through, which would give me negative 25x plus 25. Now I need to see if I can get this equation to match one of the equations that I have in my choices. What I'm going to do is add 25x to both sides. That would put the 25x out here to the left, and this 25x would be gone. I'm going to add 7 to both sides, so that would leave me with just a positive y right here, plus y. And if I add 7 here, that will be gone. Add 7 here, that will be 32. And that is choice A on your review packet for number 2. That's the equation of your tangent line to this curve at the point 1, 7.